Questions here. Does anybody have homework questions on stuffs? Luke?
Number 15.
Okay, number 15.
Oh my gosh, it worked!
I read it. I was just really struggling with the setup.
But which section? Okay.
I tried doing like 4 times in class. Yeah,
there's no way he's going to be able to
All right. So we're looking at section 6.3, number 15 here. Luke, I'm going to just use the computer to generate a picture. Are you okay with that? Okay. I assume that this set of stuff is fairly straightforward as to like how to generate a picture for that. I just want to have something to draw on, and this is a little bit faster and easier than anything else, or than constructing it by hand anyways. All right. So we are rotating about x equals 2. So that's like over here. So for the record, this one is really no easier to do by shells than it would be to do by washers. At some point, that's an important thing to start talking about, is like, when is this kind of necessarily a shell problem, and when would it be just as easy to do it as a washer or disk problem? So what's this kind of look like? Well, it's going to be like, you have like a pipe, but like the outside of the pipe is like, it's like doing one of these. Does that kind of visualize that? Okay. So integrating here, with what variable would we want to integrate with respect to? Yeah, it's always the opposite of the axis of rotation. So if you're integrating vertically, or you're rotating about a vertical axis, you want to integrate horizontally. It's the opposite for disks and washers.
Disk and washers, if you're rotating on vertical axis, you want to do it with respect to Y.
Yeah.
But for when you're doing
shells, it's the opposite. Yep. Yeah, that's a good rule to go by. So we're going to be integrating from 0 to 1. So that's the meat of our interval there. So if I pick a random x from inside of that interval, that's like the radius for my cylinder, and this would be like the height of my cylinder. Is everybody okay with that? So my radius is going to be, well, let's think about it for a minute. This distance is 2. This distance is x, because that's the point xy. So r is going to be 2 minus x. So I have 2 pi r. And our height then is just the y-coordinate, right? Because we're just going up from the x-axis to the function, which was x to the 4th. So that's our setup. And then it's just integration time. I'm going to stop here because usually you guys have been pretty good on the integration part. It's the setup that's usually the challenge. In the interest of covering more and having more time to work on stuff in class, I'm going to, unless you really want to see the integration, I'm going to stop at this point. Victoria?
Could you do 19 on that same?
Yeah, sure. This is 6-3 we're doing right now. So again, I'm going to use the computer here to generate my pictures. And then let's put in y equals 1 there for me. Okay. Whoa. Okay. So we're integrating here about a horizontal axis, so we're going to be integrating with respect to y, and we'll go from 0 to 1 because the meat of my function that I'm integrating is there. It's okay with that? Okay. So if I pick some random y coordinate, and I track over to this point, this distance from the axis of rotation to my point is r, and this distance through the meat of my function is my h. And that's kind of always how we're going to be drawing our r's and h's. The radius should go from the axis of rotation to the curve, and then the h should go through the curve, through the meat of the curve, the part that's going to become a solid. Okay. So let's figure out what r and h are then. So we know that this distance is 1. We know that this distance is y, so r is 1 minus y. Similarly, we know that this distance is 1, and this distance is x, so h is 1 minus x. But I don't want it written with an x in there. I need to be integrating with respect to y, so I have to rewrite x in terms of y. So the equation for that curve was y equals x cubed. So I know x is the cube root of y. And I'm just going to write it as y to the 1/3. So I have 2 pi r times h. And then it's just integration time from there. Does that feel okay? Okay. Nico.
Can you do number 25, same section?
Sure. Let me drop in those problems for us. So same idea here, it just then instead of doing the integration by hand, it's asking you to use your calculator to do the integration, which is fine with me. And in fact, I think there'll be a portion of your guys' test that'll be similarly formatted, where I just basically ask you to get me the setup and then do the integration on your calculator, just in the interest of like making it doable inside of a class period. So I think that probably most of these volume problems will be set up kind of that same way on the test, where you'll be using your calculator to actually do the integration. All right. I'm going to use my program here to draw my picture here. And I should have picked the trig. So 0 to pi ends right about there.
When I grabbed it on my calculator, it like stopped at like y equals 2 or something. It didn't keep going like yours, which is why. Like it did the y bounds where.
And it was, you were in radian mode?
Yeah.
Huh. Let's look real quick. Oh, it might have been.
In terms of x though.
Yeah. So. Yes. Because the square root of sine y, maybe? So what you'd want to do is you'd want to actually be graphing like sine inverse of x squared.
Yeah, that's what I grabbed.
Okay, so that's the issue, because sine inverse, the range of sine inverse goes from negative pi over 2 to positive pi over 2. So you're not getting any input past or output past that, which is why you're getting, zoom trig. That's why you're getting just this instead of like it keeping on going, which is rough on what you're going to do by hand there. But this is, this picture is what's going on, if that helps at all. I don't know.
Yeah, that's good.
Okay.
Yeah, thank you.
Yeah, so drop that in. We'll kind of continue on with the setup here. But that's a great question as to like, why is it stopping? And like, what would what does this thing look like? All right. So we have the region between here is kind of our region, and we're rotating that way. So we want, again, do a dy, right? And should be easy to see that's going to be from 0 to 4. So if I pick some arbitrary x, that's like the height, and that's like the radius. So that radius should be four.
I had sine inverse of x squared, or in terms of y. That's okay.
Yeah, the radius should be 4 minus y, and then the height should be root sine y.
Thank you.
Yep, and then that should be good.
Why is the height roots? Oh, because like the height is just x, and then x is equal to.
Exactly. Yes. 100%. Very good.
Okay, this is like not that hard. It's just like the picture that I just don't.
It just takes some practice. It just like anything else. It's getting used to it, but there's a lot of layers to get through for the setup to start feeling comfortable. But it should start feeling comfortable here by the end of these homeworks, where it's like, okay, I can do this, like still maybe need some practice or whatever, but I feel like I understand what to do to get these things set up. Today,
Mr. Cole,
yeah, sure.
So for that problem, it said the bounds of integration will be 0 to pi.
Are they integrating with respect to x?
No, they're still integrating with respect to y. Is it just because in the equation, or in like the question, they had 0 is like they kind of.
Oh.
For like a circle.
Oh. I'm so dumb.
Okay.
Here.
Yeah, I did this.
So really what we have, let me just change this real quick.
Yeah.
That's really what we have.
If it doesn't, why is it when you go to the x, it's like horizontal line, so basically it's gonna be the same line. So it is the opposite.
So there you go. That's what happened here, Luke. Yeah, you're dead on right. I just missed that inequality there that's saying like we're only doing this for a little stretch.
Okay, so they just defined it.
Yeah.
Where you pretty much.
I'm studying.
Yeah. But otherwise, all the rest of the setup is still the same.
Wait, so it's not 0 to 4?
Correct, and the reason it's not is because they told us that y is bounded between 0 and pi.
So then what
That doesn't affect r or h on how we came up with those.
okay.
It's just saying that the function stops at when y is pi, and so there's like a lid to that rather than it going straight up to the axis of rotation. There's like a hole in the middle now, which is fine.
In this question, can we use the other one?
A washer?
Yeah.
Yeah, I think a washer would work appropriately in this as well. I think the directions say to... it doesn't say what you needed to do, so yes, you could have done this with a washer. I think it'll come out to be the same thing. Okay. So today, what I'd like you to do is find someone or someones, it doesn't matter to me how many people, to kind of work together. You're just going to kind of work on 40 or 37 to 43. Just worry about the setups. When you think you have a setup correct, come and ask, and I'll tell you if you got it or not, or if there's a problem with it and kind of where that problem might lie. But the whole point of today is to kind of get some practice here on doing this process. Now notice the directions here. So there's going to be discs, washers, shells, all possible here. And really, for these problems, any of these are going to be possible. But I'm going to tell you what. Usually the shell ones are going to be like infeasible for you to set up as discs or washers. Like it'll be, like I'm not sure I would know what to do to kind of get it to cram a washer disc into a shell problem. And likewise, like the disc and washer things are usually much easier setups than shells if that's. So it's about like finding the easiest way to do it. So keep that in mind as you're working. Again, find somebody or some buddies. It doesn't matter to me how many people you want to kind of create your brain trust with. But work through these problems, talk it out. It's really important that you're communicating to one another, that you're talking about what to do, why you're doing things, like how you're generating your picture, where the parts are, how you're defining, your radius or your heights or whatever, depending on the method, how you can choose which method to use. Again, if you have questions about things, please ask, even if it's just like, hey, for blah, 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 can I do a disc? Or a wash, like even asking like before you get too deep into it, what method, if you're not sure, feel free to ask. That's what we're doing for the period though, is we're just working on these. Don't worry about the integrations, just worry about the setups right now. Like we want to try to do as many setups as we can inside of the class period. When we did this first hour, I think the fastest group, got all the setups. So once you kind of get going, things should pick up and it'll go a little bit quicker. But don't be afraid to ask if you're not sure what to do. If you need to get up and move around so you're by the people you want to work with, go ahead and do that. Okay?
Sergio is not invited.